system called Riemann. I don't know how many of you have heard it, but if you have, then good. Okay, so Riemann, it's a monitoring system and event processor that helps you monitor your distributed systems. It can very easily tell you what broke, where did it break, when did it happen, and much, much more. Riemann can accept events from multiple sources, as you see, and can propagate them forward to multiple outputs. You can have Logstash to monitor your, analyze your log files. You can have collect deep plugins to monitor your stack, and you have a lot of language-specific clients to monitor your application.
So, Chuck Norris handles the bad guys the same way Riemann handles events. First, kicks ass, then they lock him up, and then they wait until the event expires, which has time to live. So, the interesting part is where you lock the events. Okay? So, for each service on each host, we store the last event until a new event comes, or until it expires. And then we're going to show you some kick-ass closure code.
Okay, so the first use case we're going to see is just a very simple IBIS detection. We have two hosts that report heartbeat events periodically, and at some point in time you can see host B crashes, which means its heartbeat stopped. Because every event has a time to live, this will trigger Riemann to take some action. This is how it looks like. This is an actual closure snippet taken from a Riemann configuration. It's pretty straightforward. When the event with tag peopleIve expires, just send an email, and expired is a built-in function designed to inspect the time to live of an event.
So what this slide says is that if Chuck Norris is here, Riemann is here. Okay? Riemann can do anything you want, specifically trigger based on thresholds. And the code is really simple, a function that takes a condition, a predicate, and an action. So if it's a request latency, it's more than 10, then send you an email. Pretty simple.
Okay. This actually causes a bunch of emails now to be sent to your inbox and pollute your inbox. You can simply resolve this by having Riemann react just to state changes. So here we define that when a metric is bigger than 10, the state is error, and when it's less than 2, the state is okay. This is the code. So when the service is request latency and the metric is bigger than 10, we change the state to error with the with function, and then when the state changes from okay to error, again, we just send an email. So this will just send one email.
So, you know, they say Chuck Norris can divide by 0. So, Riemann can average even null values. So, seriously, if you have a lot of events, you want to take some kind of median average, right? And if you have a big cluster, oh my god, so you need to group by different hosts, then take each median or average, and then do the maximum, and of course, put them in the jail. So how does this look in code? Can you do that in any other tool? So this is it. Group by, then only we only choose the request latency, then choose the percentiles over the last median, call this function which just folds it the maximum into the index. That's it. Works.
Okay, this is a system described with a database, you can see here, and many web servers connected to that database, so they hold the database connection. When this database crashes, basically every server sends out a database connection error. These errors are all the same, we don't really need them all. You can filter these with Riemann by using the throttle and the rollup. This code will eventually, the end result will be 2 emails containing one event at the beginning of the hour, and another 98 event email at the end of the hour.
So this is just a simple scenario. You know, Chuck Norris, you just want to add a new key value pair to the event. That's it. If you have a good reason to do it, you can do it in any other monitoring tool. So basically what this slide says is that everything Chuck Norris can do, Riemann can do better and faster, okay? That's what you need. You can do any custom function you want that does basically anything, as long as you know closure.
So think of a multi-tenant environment, I'm sure you all use it, where you need tenant-based isolation, but you also need an overall view of your entire system. You can have Riemann forward each tenant state to a dedicated Riemann aggregator server. This is in code, so we define the TCP client to connect to that aggregator, And in each tenant server, we have it react to state changes that we saw before. We modify the event by adding a tenant key, and we forward it to the Riemann aggregator, which will now store information on all tenants. Okay, so this is Riemann, the website. You should check it out. See the video lecture by Kyle Kingsbury. It's really, really entertaining. There is also an active community up via Freenode channel and Google groups, and just play around with it.